What's up, everyone? Welcome to another episode of AI Buzz. Thank you so much for tuning in today. Today, we have some really cool things coming out of the Nvidia newsroom. So yesterday morning, Nvidia's newsroom released a summary of some of the really cool projects that they're working on. It wasn't just one cool technology that they described. Each product in this news release was mind-blowing. It's pretty funny. Every product had its own short little paragraph, like it was no big deal, but each one was cooler than the last. This is yet another reason why Nvidia is going to continue dominating the machine learning market into the future. Anyways, let's get into it. So the news release is actually a result of a keynote speech by one of the technology leaders at Nvidia. The speaker in particular was Brian Dolly, and he leads a team of about 200 researchers at Nvidia, and they have some really amazing projects. And that's what he talked about in the keynote, which then made it into the news release. So one thing that he talked a lot about was Huang's law. And this is a lot like Moore's law for CPUs, except it's supposed to be modeled after the Nvidia founder, Jensen Huang. And it's a similar concept where the performance of a graphics card, or performance of AI computations, let's just say, is supposed to double every single year. That sounds really ambitious, but if you hear some of these things they're working on, I believe it's totally possible they're going to hit that for the next few years to come. One of the really cool things that Dolly discussed was a tool called Magnet. And this is going to be used for inference or making predictions with a trained model. And they were able to achieve a speed increase an order of magnitude higher than commercial chips sold today. In order to do this, the researchers working on that project had to figure out the most efficient way to move data around in the chip. And in doing so, they were able to eliminate a lot of excess energy burn. It's pretty wild. They were able to achieve this efficiency gain purely by a software approach. The next topic is something that nobody really asked for, but it's here now. Well, Nvidia has created something called GauGAN, which is a generative adversarial network, hence the GAN part in the name. And they use this to create landscapes. And the way they use this to create landscapes is actually really, really cool. A real high-level description of what a GAN is, it consists of a generator and a discriminator. The generator tries to come up with photos or images of landscapes and then puts them in amongst a set of real landscape images. It then has the discriminator try to pick the fake one out from the real ones. At first, the discriminator is like, what the heck is this generated image that you brought me? This looks nothing like a landscape. The generator sulks and goes back to the drawing board and tries to come up with yet another image that looks like a landscape. This next image it comes back with is slightly different, and depending on the feedback it gets from the discriminator, it'll either tune it one direction or the other. Based on more difficulty telling apart the fake landscape from the real landscapes, the generator is going to know which way to tune its generated images. Doing this enough times on the scale of the GPUs that they have access to, they're able to come up with a generator that can create images that cannot hardly be deciphered between real or fake. So that's a description of their landscape generative model called GauGAN. And that wasn't actually the focus of their news release on the 14th. That has actually been out for a couple years. So Nvidia also, in addition to the GauGAN tool, has a conversational AI chatbot called Jarvis. In some sort of Frankenstein-like event, they decided to marry these two products together into a chatbot that you can ask for different generated landscape images. It's wicked cool, and they have a really awesome YouTube video of it. I'll put a link in the description if you want to check it out. Another aspect of this news release was around their new programming framework called Legate, and they say they're already testing this framework at several high-profile institutions like national labs. So the cool thing about this is you're able to write code for a single GPU, test it, and then execute that same code on a cluster of GPUs. It's sort of GPU agnostic compared to a lot of the code that would be written today. You'd write totally different code on your desktop workstation compared to a GPU cluster, one of the high-end ones. The reason this is so important is because it's really inefficient to be kind of jumping around to different code bases that are tailored for different numbers of GPUs. Code that executes well on one, you would love to translate that into code that executes on hundreds of GPUs. As a deep learning hardware nerd, this really excites me. It sounds like such a cool concept. Be working on code on your desktop here at home, and then walk over to your supercomputer and run that same exact code and watch those GPU temperatures go up and down. Watch the utilization monitors. I watch those all day long. I dream. I don't imagine I'll be working on that level of supercomputer any day soon, but I hope to one day build my own mini 4 GPU cluster that I can use for my own personal projects. The last item of the news release, in my opinion, is probably the coolest. This is based around photon connections between GPUs. Connecting GPUs was always such a cool concept. You might remember back in the early days of kind of graphics cards was SLI, connecting probably just 2 graphics cards together. Well, Nvidia is going way, way beyond that. Not only are they looking at connecting GPUs together electrically, they're looking at carrying signals with photons. That's right, electrical signals are too slow for Nvidia. So as you can imagine, these photon-based interconnects would be probably a lot faster, but another advantage is the density in which you can pack them. The companies say that they had a 10x improvement in their density using this photon approach. They talked a lot about having a future DGX version of their commercial computer that you can buy, having 160 GPUs all connected together with this approach. That's a pretty wild thing to hear because the DGX is, like I said, a workstation that you can actually buy from Nvidia. It's a total beast. They have a version that has above 700 gigabytes of RAM, which is a lot more RAM than some people's hard drives. But just imagine being able to kind of purchase off the shelf. I'm sure it'd cost a fortune, but you could purchase a cluster that had 160 Nvidia GPUs that would all be able to talk together seamlessly, potentially with this photon signaling approach. Man, those workloads would fly. Well, that's about all I have for you today. If you enjoyed the video, consider giving it a like as well as a comment in the box below. Also, tell me what you think and what you'd like to see next. And if you really liked it, consider subscribing to the channel. Thanks so much for watching. Have a good day. Bye.